Hello everyone, in today's video we are going to discuss about solid principles. So let's go through all the solid principles one by one in this video. Number 1, single responsibility principle. Single responsibility principle says that a class should have only one region to change. In other words, a class, module or function should focus on one job or one responsibility. If a class handles multiple concerns, it becomes harder to maintain, test and update because changing one responsibility might break the other. In this example, which violates single responsibility principle, the employee class is handling database operations and report generation, two different responsibilities. In this example, which is following single responsibility principle, the new class has only one region to change. Number 2, open close principle. Software entities should be open for extension but closed for modification. You should be able to add new functionality without changing existing code. This prevents bugs in working code and keeps software scalable. In this example, which violates open close principle, every time a new customer type is added, we must modify this class, which is very risky and messy. Now, in this new example, which follows OCP, we can add new discount types by simply adding new classes, no change required in existing logic. Number 3, scope substitution principle. It says that objects of a superclass should be replaceable with objects of its subclasses without breaking the application. That means if class B is subclass of class A, then B should behave like A without unexpected side effects. In this example, which violates the scope substitution principle, we substituted an ostrich where a bird is expected, but it breaks behavior. The base class assumes all birds fly, which is not true. In updated example, which follows scope substitution principle, the structure supports behavior correctly. No invalid expectations. Number 4, interface segregation principle. It says that clients should not be forced to depend on interfaces they do not use. Meaning, instead of one large all-purpose interface, create smaller specific interfaces tailored to individual needs. Large interfaces cause classes to implement unnecessary methods, leading to bloated and fragile design. In this example, it violates the scope substitution principle. Robot is forced to implement it, even though it doesn't apply. Now, in updated example, which follows interface segregation principle, each class implements only what it needs. Last, dependency inversion principle. It says that high-level modules should not depend on low-level modules. Both should depend on abstractions, and abstractions should not depend on detail. Details should depend on abstraction. In simple words, don't make your core business logic depend directly on concrete classes. Depend on interfaces abstraction instead. In this example, which violates dependency inversion principle, order service is directly depending on file logger class, which violates dependency inversion principle because order service is tightly coupled to file logger class. In the updated example, which follows dependency inversion principle, order service depends on an abstraction of iLogger. We can swap logging implementations without modifying business logic. So in this video, we have discussed all 5 solid principles in brief. If you want, you can make a detailed video describing all the solid principles in detail. If you like the video, don't forget to like and subscribe the channel.